Sometimes the Clean Water team receives questions that are relevant to a lot of other monitoring organizations. Let's take a look at two questions that share a similar answer. When using IDEX Quantitre 2000s, we often have every well show a positive. This prevents us from having an actual number for MPN, and we can only report greater than 2,419. Is there something we can do in order to get an accurate count of fecal indicator bacteria in our sample? Thanks, Barbara M. Estimado Clean Water Team. When using some of our meters, we sometimes max them out beyond their measurement range. Do I need to buy new meters? Those things are expensive, and I really need to keep the ones that I already have. Gracias. Jose C. The answer to both of these questions may be the application of a serial dilution. Today, we're going to perform a serial dilution. Not that kind of cereal, guys. Let's show you what a simple dilution could look like. Let's take a bowl with a heavy concentration of an unknown, and we'll take a subsample of that and put it into another vessel with a known volume of solution. Now we'll demonstrate a simple serial dilution, starting with a concentration in one vessel. We'll take a sample of that and put it into our second container that dilutes it, and then we'll take a sample of that and put it into our third vessel, which gives us an even further dilution. Now let's take a look at another example of a simple dilution. Here we have our surface water sample, and we have a flask with 90 mils of sterile water. We'll make sure that our sample is completely mixed, and then use a pipette to remove 10 milliliters of sample water. We'll take that and add it to the flask. So now the flask has 100 milliliters. We'll shake it all up, and then we can conduct our test. By adding that 10 mils to the 90 mils, our sample has been diluted. It's a 1:10 dilution. Measurement results from this diluted sample must be multiplied by 10 to reflect the original surface water quality sample. Now we can take a look at the serial dilution of a water quality sample. We will start with a thoroughly mixed surface water sample. From this, we will pipette 1 milliliter of sample water and place it into a test tube that contains 9 milliliters of deionized water. We will thoroughly mix this 1:10 dilution and take 1 ml and add it to a second test tube containing 9 milliliters of deionized water, which will make a dilution of 1/100. From this second test tube, we will take 1 milliliter of the diluted sample and add it to an additional test tube containing 9 milliliters of deionized water. The result will be a 1 in 1,000 dilution. From this third test tube, we will take 1 milliliter of diluted sample and add it to an additional test tube containing 9 milliliters of deionized water. This will result in a 1 in 10,000 dilution. From the fourth test tube, we will take 1 milliliter of diluted sample and add it to our final test tube containing 9 milliliters of deionized water. The result will be a dilution of 1 in 100,000. By preparing serial dilutions like this, you can lower the concentration of the analyte you're trying to measure to a level that's within the range your test method or your measuring probe can detect. Be sure to multiply your measurement result by the dilution factor so that you can communicate the full strength of the analyte that was present in your surface water sample.